Okay, so hopefully this will work. Having trouble with sound today. But anyway, you'll notice that there's this rectangle here in my 3D print slicer software. And what you can see is that it's simply a rectangle with a couple holes in it. And what this will eventually become, or I hope will become, is an aquarium glass cleaning magnet. So what we're going to do is, because it's a nice simple shape, I thought it'd be a good way to demonstrate how OpenSCAD works. And so now here we've opened OpenSCAD, and we're going to define a few things. One is the size of the magnet that I recently purchased off of Amazon. These magnets are 60 millimeters long by I think 10 millimeters wide and 3 millimeters high. I like to define the variables up top before the actual building of the shapes. I think it's easier to understand what's going on and also to manage, uh, when you need to tweak a particular value. It's easier to find that value up top and alter it there than go hunting through the code, especially if it gets long, to find all the places where you need to update it. This is just kind of a technique to preserve your own sanity. Even though in this case it's, we're building something, just a simple box, really. So here we're defining what the size of the box should be. And, as you saw in the 3D slicer tool, it's really just the two magnets with encased in plastic with a wall in the middle. So you can see there that for the width of the thing, I'm saying, well, there's a magnet, and then there are a couple walls, and then we're leaving a little bit of buffer space so that we don't end up in a situation where the hole is just too tight to get the magnets in. And then the depth is, as you'd imagine, the two magnets plus the two walls, plus the wall in the middle, and that little bit of buffer space. Now we're going to define a function for the magnet case, and we're going to call that function before it even has anything in it. Now what we'll do is we'll define a cube for the outside box, which is, the width, the depth, and the height of the thing. And you'll notice that there's a value false on the end here. And what that means is that we don't want the shape to be centered at 0, 0. What we want it to be is starting at 0, 0 and working its way out. It's a lot easier to kind of work out whether or not the shape that it's producing is correct for you, because then you can just count the ticks on the screen rather than try and figure out, divide everything by 2 to figure it out. So I just find it easier to go from 0, 0. Okay, now you'll notice that it just created only a box that's only 1 millimeter in size. And I'll sit here for a minute, for a couple of seconds, actually trying to figure out what I did wrong. And it's actually that I mistyped. A little typo going on there. Oh, there we go. So now we got the the length and the depth working, but the height is still only 1 millimeter. And that took another second to figure out that actually the values are expected to be integers. So kind of the minimum gradient, like level of accuracy here is like the 1 millimeter. So I kind of poke around a little bit, making sure all my spelling is correct or equally incorrect everywhere, and then finally it dawns on me that I can't do a 2.4 millimeter wall width. It has to be 2 millimeter, and then from there you'll see the box gets created. So there we go. There we have it. There's the outside box, the outside dimensions of our little aquarium glass cleaner. Next, we're going to
Joe.
Go. Hey, Mom.
You need to shave all of that off your face, eh?
I do. I do. How's your book? Pretty good? Excellent. Yes, I do. Now we're going to define the inside spaces needed for the magnets to fit in. So here we go with the, those spaces are going to have a width and a height and a depth, and there are going to be two of them with the wall in the middle. So now that we're defining these additional variables, we can also do a little bit of a cleanup with our initial definitions, because our initial definitions just were using the magnet sizes themselves. So we can make things a little simpler up there and reduce the number of places where we want to have to fix things if we change our minds about sizes. So what we'll do is we're gonna go in here and alter these to be the side, make the outside walls the size of the inside boxes plus a little, like that. Okay. You'll notice I've removed the buffers from those outer dimensions because the buffers are accounted for in the inside boxes, which makes more sense to have it accounted for there, because that's where the magnets actually go, are in those spaces. Okay, so that's the first box, and there's the second box. They're both exactly the same size, they're just in a slightly different place. So I'm commenting out the outside box so that we can see the inside boxes. And what we're going to do is change the color of each of these boxes so that we can actually differentiate them, which is which. And of course, I've accidentally missed a quote, but I need to figure out where it is. There it is. And okay. So now, of course, we can only see the green one because it's the last thing drawn and it's right in the same place as the red one. So we're going to move over one of them to its final location, which essentially is up a little and over a little so that there can be the plastic from the outside box around it. And that's why you see here that we're translating it, or essentially shifting it over by the width of the wall. There we go, there's the green one over. Now we're going to take this red one, I'll put it second here, and then we'll have to move it over. takes a couple tries before I get this right. So first I think, okay, well, I'll move it over a little bit, the width of the plastic, and then I'll move it um, over the size of the magnet, plus the width of the wall, plus the width of the wall again. But that doesn't quite do it. It takes a little bit for me to figure out what I'm doing wrong here as far as the calculation, but it's we get there eventually. There we go. So now they're in the right spot. You can see them side by side, that little bit of wall in between. There's the box on the outside of them. Now, of course, you really want to, what we're going to do here is use the difference function. And what that essentially does is takes the first shape and subtracts from it all the following shapes that are inside the curly braces, like that. Now you can't really see anything, so what I'll do is I'll go up into the menus and turn on wireframes. This recording actually doesn't show the drop-down menus when you click on them, but you'll see the mouse go up, and that's me clicking on the wireframe option. There we go. And you can see what it looks like. So the next thing to do is to actually compile it and then to export it as an STL file, which I'm going to do now. And here it is printing on the 3D printer. Now what I simply do is I have this print going at I have the video for this print going at a higher speed because it's like watching paint dry, these 3D printers. But here we pause the print, drop the magnets in, like so. You notice that there's a little bit of Sharpie on the magnets. That's to make sure that the same pole is up on both of them, so that way we don't get a weird situation where the second box doesn't attract to the first one, because we will have to print a second one in order to get the magnet on the inside and outside of the aquarium. So here we continue to print. Here, when it's deep enough, what you're going to notice is you're going to see the printer start to try to close those gaps. It is a wide gap for the 3D printer to do, so it doesn't actually succeed on the first pass, but I have a few passes. I have it calibrated to go for 5 or 6 layers before it for the top and bottom. So it does actually make it across after a couple of layers. And here it is, kind of getting ready to finish up. It's managed to close the gap altogether. And I have it ironing at the last pass. Just want to make sure that there are no little tiny pinholes in the print. And that's it. It's done.